Okay, Liz, I'm going to stop my video and let you take over. I will, again, if you want to ask Liz questions, you can use the Q&A button or the chat feature, and we'll answer those at the end of our talk. Again, if you're on the app, you can type it in the session Q&A and chat also there. Those show up here too. Thank you. Liz, take it away.
Great. Thank you so much, Mario. And thank you for hosting. And thank you all for coming today. Today I'm going to be talking about a project I did over the past couple of months called the BLE MIDI Robot Xylophone. And basically it is a xylophone that takes in MIDI data over Bluetooth, and it has these tiny solenoid motors that you can see here, and it strikes the notes when the notes come in. So just a little bit of backstory on this project. I'd actually wanted to make this for, not to age myself too much, but almost a decade. In college, I majored in music technology. I became really curious about MIDI, and that's actually how I started to get into Arduino and electronics, everything I do today. And I actually had wanted to incorporate a project like this into my senior thesis, but I was at a small liberal arts school, so there really wasn't like computer engineering or anything like that on campus. So kind of took a back seat. So finally, this past summer 2019, I started working on it, and I called it the Xylo Pi. And the reason why I did that was I was using a Raspberry Pi at first. I was using these Darlington drivers, ULN 2803s, to drive the solenoids and some multiplexers to make sure I had enough inputs and outputs. And everything was working really well. With the Raspberry Pi, you can do MIDI over UART. So that means you can take a MIDI 5-DIN connector and connect it directly to the GPIO pins to get a UART connection. And just like a simple circuit on a breadboard, you can have MIDI in or MIDI out. So if everything's successful, I want to move on to the next point, which I want to make some custom PCBs. But as you can see here, things didn't go too well. One thing I did that you should never do was I changed the circuit from the breadboard to when I did the PCB. So basically what I was putting onto the PCB, I hadn't actually tested in real life. And also I was trying to do a little bit too much at once. Back here on the breadboard, I was just taking in that MIDI data and it was working. But for the full thing, I also wanted it to be kind of an analog circuit as well, where you'd have, I want to do arcade buttons to be able to hit the different notes and have it be interactive. So like, you know, if I brought it to like a maker faire, people could play it and interact with it. But that was abandoned, and probably a good thing because, you know, we can't touch anything anymore in public. So what ended up happening was there were logic level issues, meaning that with this circuit that I chose, with the buttons, it was looking for 5-volt logic from power supply, which works fine, but the Raspberry Pi only outputs 3.3 volts from the GPIO. So it was just kind of a big mess. And I didn't really figure out what was going on because there are other issues with PCBs until about the third iteration. And at that point, I was feeling pretty discouraged. So I decided to take a break. That was around November. But then in March, pandemic hit, and I decided I'd been wanting to revisit it anyway. And with all this time that I had at home, I figured what a great time to revisit it. So I hooked everything up again. And between the time that I'd stopped working on the project and when I picked it back up, I'd started writing a lot of learn guides with Adafruit. And I thought it'd be fun to do a learn guide with this project. So I reached out to them to ask if they'd be interested in it for their learn system. And also it would give me a deadline to help me motivate to finish it. And they were interested, but they asked if instead of with the Raspberry Pi, could use one of their NRF52840 boards. And that's boards that use the NRF52840 processor so that it can transmit Bluetooth and also run CircuitPython. And they also, with CircuitPython, wanted to use, at the time, new BLE MIDI CircuitPython library. And at first, I kind of took the night to think about it because I had put in so much with the Raspberry Pi that I was kind of attached to it. But then I realized it would be a really great way to kind of rethink the project and approach it with kind of fresh eyes. So I said, of course, and this is the circuit diagram that ended up going with the project. Started using an itsy bitsy NRF52840. That's, I think, the smallest board that they offer that has the NRF52840 processor. And the reason why it can be so small is the only pins besides power and ground is I2C. And I2C communicates with these MCP23017 multiplexers. And what those do is they allow to have 16 on each of them inputs and outputs that add on. And it's just controlled with these 2 pins from the processor. So that really opens things up. You're not having to depend on your dev board for all your inputs and outputs. So the multiplexers take in the on-off data from the NR5240 that's taking in the MIDI data, and then the multiplexers take that input and output data and output it to these Darlington drivers, the ULN2803s, which I had originally been using with the Pi. And what these do is they can take that 3.3 volt logic that's traditionally found on these microcontrollers and up it to 5 volts to drive these solenoids, because there are 30 of these little things. And they take 5 volts and they also pull 1 amp. So they're really great for kind of a low powered solenoid project, not taking a lot. And also because of the nature of this project where it's quickly striking the note, they're only actually on for fractions of a second. So you don't have to worry about having to have a really like beefy power supply. You can kind of get away with something smaller. And because it was a native fruit learner, I was able to collaborate with Noé Ruiz on the mounting design. For those who don't know, Noé is just an amazing designer with 3D printing. He designs things so that they print with no supports. And so he designed an 20 by 20 aluminum extrusion based design, which is really cool. Makes it really modular. These mounts for the solenoids are able to slide on and be adjusted so that you can get the perfect height for striking. And then I was also able to attach these kind of aluminum add-ons and 3D printed add-ons, because it was in the height of the pandemic here in the States, so I couldn't get a lot of these parts, so I actually modeled them and 3D printed them so I'd have enough. And that allowed me to mount the circuit kind of onto the xylophone. And just give some more hardware glamour shots. Really with Noé's design, this made this project possible. I just don't really have these skills. So you can see how the solenoids kind of press fit in here. They can be adjusted. And then these are the legs that hold up the aluminum extrusions. And it also allows them to be at the perfect angle so that they are over the keys right in the middle, where you can get that really great response from the solenoid for the notes. And of course, you can't have this without code. So it's written in CircuitPython. It's basically a lot of arrays. You have arrays of the solenoids for digital outputs, and then arrays of the MIDI notes. And these are predefined notes that match up with the glockenspiel's notes. And then in the loop, it's actually really simple, especially if you've played around with MIDI stuff before. All it's looking for is that note on message from the MIDI. And then if the note number in the note on message matches one of these arrays, it strikes a solenoid, and after a quick delay, it retracts it. And that's it. The CircuitPython libraries for MIDI and the multiplexers, that's what this MZP is right here, makes it so that you really don't have to do a lot of hard coding or bit banging or anything like that. It makes it really easy. So if you're into MIDI, definitely look at the CircuitPython stuff. And then wiring, I ended up going with the half-size proto boards kind of as a nod to that original prototype that I had going with the Raspberry Pi. Because with all this wiring, this was one that was about half assembled. You have this bunch of wires here and here. It ended up that on this side of this multiplexer and over here too is all bunched up in wires. So with the breadboards, these are all power rails. So as long as you have something soldered in here, you know that it's connected to this pin without having to make sure of the connection. It's just already on the board, which really takes a lot of the effort out. It just makes it really easy. And the biggest thing of this project was to test as I go. It's huge assembly. So if you're ever working on a project that is so involved, like definitely kind of pause. It can be really tempting, just solder everything up and just go head first. But I really made myself pause and test. So what I did, especially with this, was there's 30 solenoids that would eventually be taking up this whole extrusion here. So I wired up the solenoids to be kind of in the middle, meaning that there would be 16 on this multiplexer and 16 on this other multiplexer. And that means that you're testing I2C communication between the two multiplexers and also to the itsy bitsy right here. And then you're also, with how it's spread out, using a Darlington driver on this board and over here as well. So you're really testing all of your connections, and it makes it easier to spot any trouble shots or shorts or anything like that. And unlike if you were to solder everything up, go to play and, well, these notes aren't playing, but these are, and you have to take everything apart anyway. So definitely testing as you go is good. And then kind of like a cooking show, it's all set here. And as I said, like the biggest assembly I've ever done for a project, also the largest documentation project as well, just because there's that Adafruit Learn Guide. So that means everything, including the assembly for the mounting hardware and how to connect the solenoids and even how to set up the MIDI is all documented. And that was one thing I was actually really excited about for this project, just because it had been so long in the making that now someone wanted to recreate this. And you totally could, because these xylophones actually are pretty common in the States because music programs in public schools use them. That's how I got mine. I've had mine since I was about 11 years old. So there's a lot of them on eBay and Reverb and all that for a really reasonable price. And also if I ever want to revisit it and I'm like, how did I do this circuit again? Or what was I using? I can go back and reference it. But if I just have like kind of a sappy feel-good moment for a second, like this project, I think in general, I'm a perfectionist. I think musicians can be perfectionists too. And where this project was just so long in the making that when I first attempted it, I kind of basically fell on my face and had some pretty big mistakes. It kind of shook me a bit. So to just show like you can say, okay, I messed up, step back, and then pick it up a little bit later and get it working. That was big for me. And I hope that if anyone's ever kind of had those feelings, like you can go back to projects you've started or other things and be confident that you will eventually get it. But that's gonna do it for my slides. So we can go into the demo and Q&A portion.
You want to demo first?
Sure, yeah. I've got a camera set up. In back of me is actually the xylophone. It's a little blown out because I've got some lights on it because it's a bit dark here today in the Northeast. But that is the xylophone. So I actually built a shelf last weekend for it out of some plywood. And so I've got a little MIDI keyboard on my desk right here. So you can see there's a C chord. And if you look really carefully, I'm kind of playing in the lower register now. You can see the solenoids like reacting and hitting the notes, and it's very responsive. And then I'm actually going to switch over. I'll keep sharing that screen, but I'm going to switch to some MIDI output because I think there were some questions about if there's any latency. So I'm going to play some MIDI data so you can see what that's like. And you can see it's very responsive. It's staying on beat. We're at 170 beats per minute right now, so that's pretty impressive. And so I'll pause that and then go to another one. So it's pretty quick. And part of that is I've also updated the code a bit so that instead of using time.sleep, I'm actually using time.monotonic. And what that does is it almost lets you kind of multitask in Python, where instead of stopping the entire code and waiting whatever time period you're looking for, it's actually counting seconds. So it kind of marks time like, okay, you did this action at 15 seconds in and you want to move on 5 seconds later. It will kind of pause that, but allow you to keep doing other things. So that's really great for this project. And actually how I came about that was, you can see on the table, there are those little kind of mallet things. That was a project I did last week with Nai, actually, that is a MIDI drummer. And so with drums especially, like you're having to hit things at the same time and stay on beat. So we kind of came up with that for the code so that it allows things to happen at the same time. I just updated the xylophone code to do that, and I'll have a pull request in probably this week, so they'll update in the Learn guide as well if you want that updated code. So. Mario, I don't know if there's any questions.
Yeah, I guess the first question is, on the bells, are you hitting polyphonic due to current draw on the solenoids? Are you having issues hitting polyphonic notes on it?
Nope. Let me switch back to MIDI throughput.
Yeah, you play the chord, so the chord
yeah.
works.
And I'll play two hands just to show a lot of notes. So definitely working with polyphonic, which is good.
I guess somebody liked your choice of music, so it's a nice choice of music.
Oh, thank you.
On the theme song there.
Thank you.
Have you seen any issues? Have you tried doing that with like running some sort of arpeggio, like again the MIDI clock?
I have actually. There's a arpeggiator on this keyboard. I can try really quick. I've done it before, but yeah.
Wow, that's pretty quick. It's awesome.
Yeah, it's very responsive. Yeah. So my goal, something I'll be working on next is looking at MIDI USB hosts, which allows you to play MIDI instruments with USB without a keyboard. So I want to hook something up so it allows my keyboard to connect directly to it, so I'd be able to play live when I'm doing synth things and things like that. So that'll be coming soon.
Did you always start on CircuitPython, or did you start when you started, you wrote it on the Raspberry Pi? Did you start it on Python and then moved to CircuitPython, or
Yeah,
you always started on CircuitPython?
Yeah, on the Raspberry Pi I was actually using CircuitPython for the Raspberry Pi, which is called Blinka, and that allows you to use the CircuitPython libraries on Linux-based single board computers. So actually bringing that code over to like regular CircuitPython, it made it really easy because there were just a couple minor things I had to change that were more kind of with the MIDI aspect, like not using MIDI over UART, instead going to the BLE MIDI library. So yeah, it's always been Python based.
Okay, and then you use the perma boards. So can we talk about the stuff you use from Adafruit? I know you had, I'll let you talk about the project. I know if you can also post maybe into the chat, Liz. I don't know if you have it.
Oh yeah,
I see Noah's on here too, but
yeah,
I can make him a co-host. But maybe if we can post a Learn Guide on here.
Yeah,
let
me bring that up.
I'll post that also in the chat on the piece. And also the drum one, because I saw the drum one too. I love that one too. So if you could post both of those, I'll share them within the on Zoom here, and we can share them inside the app.
Okay, here is the Learn Guide link for those interested, and then let me bring up that drum guide. Here's the drum guide. So yeah, for Adafruit is using the Itsy Bitsy, which is kind of their small board, and then they do sell those ICs as well. So you can get those there, but you can also get them from really any electronic shops like DigiKey, SparkFun. I wanted to use that MCP multiplexer just because it's really common, and the ULN 2803, which is the Darlington driver, it just makes wiring up the solenoid so much easier than if you're doing the other circuit I had tried to use previously, which is has the diode and the other electronics. It just makes it a lot easier because you're just with that IC, you're just doing like point-to-point connections basically, and the actual like conversion of the electronics is all happening inside the IC. So you don't even really have to think about it. You just have to make sure you're connecting everything at the right spots.
What are you going to use to do the host media? You can also use one of the Adafruit. I know that there is a MIDI tutorial out there. I think it's by the Ruiz brothers also. Can you use that as your host to run the Mac? I mean, so could you put that in front of it and actually just load up a whole bunch of songs and have like a piano roll type sort of feature where basically somebody can pick songs?
You could definitely do that. That was one reason why I was looking at the Pi originally. But you could definitely load up MIDI files and kind of have them play automatically. For the USB to USB host, I'm actually looking at using a Trinket M0, which is kind of Adafruit's smaller little board. And John Park, actually, who's giving a talk at 3, he worked on a project with another engineer, Todd Bott, which allows you to take 2 Trinkets and basically connect 2 USB peripherals to them and kind of act as a bridge so that the USBs can talk to each other without the computer.
So here's a question from Cedar Grove, which is also another awesome music maker.
Yes, he is.
On the webs. What was the process for turning the solenoid on time? What was the ideal duration?
So the ideal duration, I can actually look that up really quick because I'm forgetting on the code, but I believe it was 0.03 seconds, if I remember correctly.
Yeah, maybe if you, oh, okay, I see it now.
Oh, did my screen stop sharing?
I think we're back.
Okay.
Yeah, so then, and then that's the firing time? And
yes.
Then, yeah. Okay. So there's any other questions? Checking back on the.
Thanks so much, Joanne.
Could you run these in parallel? Could you run 2 systems in parallel?
Meaning to MIDI controllers at the same time. If you set up your MIDI software, you could set it up so that both were firing. I have had two CircuitPython based MIDI controllers connected, either Bluetooth or USB, and they do work. It's same as if you had multiple keyboards connected or things like that.
Checking for some more questions.
Gotcha.
Will we see the xylophone and the drum working together, maybe for a song?
I'm hoping to. The MIDI solenoid drum kit, I actually didn't have time to fully assemble it. The code is actually basically the same as the xylophone code. It's using the same ULN 2803 driver and the same kind of concept of it receives the MIDI note, it strikes, it retracts. So I do want them to be playing together at some point. And Nai also did a great job with that assembly as well. That was also his work there.
Do you know if any CircuitPython supports internal MIDI clock? That one's from Rodney. Example, a 96 PDQ.
I believe that you can do MIDI clock. I know that I think the Neo Trellis, John Park might have done a project with the MIDI clock, getting clock out of the Neo Trellis. So there would be support in the library for that. And you can also just in general do a lot more MIDI than just note on. You can do all the different parameters. And I also did a MIDI guitar. And on that, like we were affecting velocity, we were all the kind of stuff. So there's a lot in that library and they're still adding to it. A lot of the CircuitPython developers are also hobby MIDI enthusiasts. So there's definitely going to be a lot of stuff coming out of that.
What's the collective power consumption? How big is that wall work? From Cedar Grove again. Like everybody's scared about the power pull.
I know, yeah, and a lot of people also told me it wouldn't work because of the power. That was going to cause everything to blow up. But because it's just the 5-volt solenoids, I'm able to use a 5-volt 2.5 amp wall wart. They only pull 1 amp at a time, and it's on for a fraction of a second. And so they are never, with the nature of the code and how stuff works, they're never all on at the same time, and they're never, like if I hit a chord, all 3 of them aren't like pulling power altogether. So it's fairly low power. If you were to go up in solenoid size, then you would definitely run into some issues and you'd want to do a separate power supply. And actually for that drum project that we just did, we actually went to 12-volt solenoids and we have it running on a separate power supply to power the solenoids.
Is the draw on the drum arms different from the ones you have on the xylophone?
Yes, yeah, I think those might be 2 amp if I'm remembering correctly. They're a little bit heavier.
Checking, one second.
Yeah.
What is your next project you're working on? I guess I asked you about the drum and the piece, but what are your projects you're working on, and what is your inspiration for some of these projects?
Gotcha. So I can plug it in. I just started working on a stream controller with CircuitPython. Plug it in real quick. And it's using a Pi portal. And basically what it allows you to do is live demos. But basically it allows you to do is to have these buttons for different programs and have all the hotkeys programmed in so that if you are trying to have shortcuts, they're all programmed and you can just press some buttons. So I have things programmed for Zoom. Everyone's using Zoom, including us right now. Premiere for video editing and things like that. So that will be coming soon. And then also, I've been doing a lot with the pocket operators, which is little like kind of calculator size synths. So I want to do some project with that, like modding them. And so a lot of music stuff and USB things.
I guess back to some power questions. Do you have big
Yes.
caps on there? Again, from Cedar Grove.
I do not.
I used to plug, so yes, I saw your design and I didn't see anything on there, so that's why I asked about latency. Maybe you were doing something with latency to get around that, but I guess they're not firing exactly at the same time, so that helps in the power.
Yeah, and I also with these CircuitPython things, like if anyone was there for the early days of Arduino and MIDI, which I'd experimented with basically zero programming background, so that didn't help. It was always a challenge to get them to be recognized by your DAW and everything like that. But DAWs in general, I think, have come a long way with MIDI, especially with like USB MIDI being so much more common now, that the CircuitPython stuff is recognized really instantly. And I haven't had to adjust the latency. With the Bluetooth stuff at first, I did a bit, but then there have been some improvements to the library, so that makes it a little bit more solid, a little bit more responsive.
Okay, then if people are interested in following you, how can they follow you? Where can we find things from Liz in Blitz City?
So I put out YouTube videos about every week. Channel name is Blitz DIY, and then I'm also on Twitter and Instagram. Also Blitz DIY there as well. So I post fairly regularly because I'm always working on stuff. So
I will post those to the web app chat and to the community chat, so that you'll have all of Liz's information. I think she's definitely one of the people that I discovered this year, and we're excited to have her on today. So I am a fanboy as much as I am a moderator here. So I asked some of these questions myself before she even got on. So on the MIDI projects, obviously you see there's a lot of folks, again, like John Park, and I mean even Cedar Grove. There's a whole bunch of people adding to the CircuitPython stuff, and mostly around the Neo Trellis. So I've worked on some projects on Neo Trellis. I guess that if you wanted to use that as a source, that could be something you could actually build a keyboard on a Neo Trellis to actually play the xylophone, right? You could actually have
definitely. So
that definitely has everything they would need to do that. Again, all these are Adafruit projects. You know, this isn't sponsored by Adafruit.
No,
we're just fans, and that's where we buy our stuff. And so
yeah, with CircuitPython, they released that programming language. I think it was about 3 or 4 years ago it really started, and I had always really struggled with Arduino, which is C-based, and because I don't have any programming background, I'm completely self-taught, and then like growing up I wasn't really into computers or anything like that, so coming at it from a complete newcomer perspective with Arduino, I was always really relying on like example code, and I could never really figure out how to like make stuff do something that maybe wasn't already there. So with CircuitPython, for me, and I've heard this from others too who have a similar background to me, just the way that you write it, the syntax makes a little bit more sense because it's a little bit more almost like based in the vernacular, so that you're not having to think too much about the syntax. It just makes it a lot easier to write, and I've definitely been able to write projects that I never thought in a million years I'd be capable of coding. And with the library support and everything, I think it's really something to look at if you've struggled with coding, but you want to make projects. Like definitely check it out. And that's why I use it, and also use the Adafruit microcontrollers too, just because the support's there, the community's there, and it just makes it to be this really streamlined experience for making your projects.
Yep. And again, the learn guides are pretty amazing. So usually,
yeah.
Obviously now you, but me and John Park's learn guides, some of the learn guides are usually how I figure out how you guys do things and then how to hack that away.
Right. And they have these really, like, the reason why the learn guides are so awesome is they have these really strict standards in place just for how everything is set up. And so that every one of them, conveys the information correctly. They're all reviewed and everything. So having that resource there, and now that I'm able to contribute to that community resource, it's just really awesome. It's just such a great community setup.
Okay, I think it's all the question is. If you want to, close it up and wrap it up, and if you want to stop the share so we can all see you, and I will mute myself. But again, we love that you're on. We love that you were here today. We love this project. We love all the projects you're working on. I think, like I said before, this video will be posted shortly later today inside the channel for Liz. It'll be on the chat for Liz, and then it'll be in the community center where we have a space where we're putting all the chats. We opened all these to be unlisted as soon as they're posted. So if you go to the Maker Faire link, you'll see all of them there. And then I'll turn it back to you, Liz.
Great. So thank you, Mario, and thank you everyone from Miami Maker Faire organizing this, and also thank you all for attending. I know Saturday afternoon be a little tricky, so appreciate it, and thank you. Hope you have a good one.
Thank you, everyone. Thank you, Liz. You're the best.
Thank you. Bye.
Bye, guys.